Starting with version 12.131, a professional license of EES can be called from other applications using the SendMessage command from the Windows operating system. So EES will now respond to a SendMessage command that has the format that's shown here. So the first parameter, the first argument here of the SendMessage command is hwind. It's the Windows handle of an open EES program. The second parameter here, wm_run EES, is an integer message type that EES is programmed to recognize. So you have to set it to 32777. That's the integer that EES recognizes. The third parameter, em_command, is an integer that specifies what action you'd like EES to take. So there's a bunch of choices that are listed here. The first three choices correspond to manipulating a log file that will log the commands executed during the process, which is really useful if you're trying to debug what's going on. The log file itself is going to be maintained in whatever folder you have EES installed in, and it's going to be called EES call from app.log. So if you send a 0, which is em delete log, then it'll delete the log file. If you send it a 1, so em log off, it's going to turn off logging. And if you send it a 2, so em_log on, then it's going to create the log file if it doesn't already exist and start logging to the file. The next two options tell EES what action to take, and these include 10, so that's em_solve, and this just says execute the solve command. So this is exactly like you selecting solve from the calculate menu. And 20, so em_run macro tab, will run a macro that is open in an EES application. So the macro that will be run is going to be the one that has the tab number provided by the fourth parameter here, which is extra. So this parameter extra should be set to 0, again, unless you're using this last option, em command, or 20, in which case it should be set to the tab that contains the macro that you'd like to run when EES is called in this way. So you need the window handle, hwind here, and you can find that window handle in a couple of ways. One is a call to the find window command, which is shown here. So if you're going to use this, you need to use TES_D to specify that you're looking for the EES application. Another way is to use the get processes by name command, which returns all of the processes that are named. Here you can see they have to be named EES. If you want the first of these windows, then you just take the handle returned by the first element of P. The format here is for MATLAB, which is the subject of this video, and in MATLAB I found that the second option, the get processes by name option, is easier to make work than the find window command. So that's what we'll use in this video. So this approach will keep EES open and ready to respond to commands that are issued by the calling program. Passing data to and from EES can be done using data files, and the interaction itself then is relatively fast, as EES will not need to close and restart before each command. It'll just sit there open, waiting for you to send it commands. This approach is going to work for any application that can issue these Windows commands. In this video, we're going to specifically focus on MATLAB. So let's do a simple example here where we call EES from MATLAB, and we use EES to calculate a thermodynamic property. So I'm going to start MATLAB, and the first thing I'm going to do is create a folder. We'll call the folder MATLAB example, and within MATLAB I'm going to navigate to that directory. And there's two files that you're going to want to put into this directory. Both are included with this video. If you download in the description the zip file. One is the function prototype file user32_proto.h, and that's going to hold the send message function definition. And the other is the class definition file EESConstants.m. that's going to define the constant values that we just saw in that table, and these are the values that are used in the MATLAB to EES interface. So let's write a third M file here called volume.m, and this is going to contain our function. And this function is going to take in a string that specifies the fluid, and then two numbers that specify the temperature and the pressure. So together these will specify the state at which we want to calculate the specific volume. So the function is going to return that specific volume at that state calculated from within EES. So because we're going to communicate using data files, I'm going to start by declaring a string called folder, and that's going to contain the path to the folder where we're going to write the files. Within the function volume, then the first thing I'm going to do is try to write this information, the fluid, the temperature, and the pressure, to a file that EES can open in order to gain access to these input arguments. And this is going to be done using the fopen command to open a file called state.dat within that specified folder, and we'll open it for writing. If the file comes back as -1, then MATLAB wasn't able to open it, and so we should put up an error. Otherwise, we're going to write the string and the numbers TMP to the file. And you notice here that for EES to recognize the refrigerant name as a string, you have to add single quotes to it on either side of it, and that's done with this formatting string that's right here. And once that's done, then we're gonna close the file. So we should stop here and just verify that everything's working right. So and that means basically verify that I can write this file and it looks okay. So here, let's just return v equals 1 to avoid any errors. And I'm going to call the function from the command line here with, I don't know, R134A at some temperature and pressure. And what should happen now if I go to my folder is I should see the file state.dat just sitting here waiting for EES to open it. So the next thing to do, probably before we keep going in MATLAB, is go build an EES program that's going to open that file, read it, and write the specific volume to another file that's then available for MATLAB to read. So there's a few ways to do this, but here I'm going to open EES. I'll use the $import directive to open the file and import those 3 parameters. This gets executed before anything else happens, so it's going to happen in the right sequence. I'm going to set the unit system, as I always have to do if I'm going to access thermodynamic property routines. I'll calculate V using the volume command, and then I'm going to execute a $run macro after directive to export the value that I just calculated of V to the file v.dat in that same folder. And $run macro after will happen at the very end. So the sequence is perfect, right? We're going to import, we're going to calculate, and then we're going to export in that order. And I can pretty easily test that this also works. So I'm just going to solve here, and if I run EES, I should see that if I go to that folder, now there's a file called v.dat, and if I open that file, you can see it does contain the specific volume. So one of the nice things about this approach is it's pretty easy to debug sort of in isolation these different processes. So now let's return to MATLAB and just finish the process. So if it's not already loaded, I have to load the Windows DLL file user32, which allows MATLAB to access the Windows API functions. So the one that we are going to use is the SendMessage function, and the function prototype file tells MATLAB which function we're going to use and how it's called. The last 2 arguments here give the library the name or the alias user32. So back in our volume function here, we're going to use the get processes by name command to find all open instances of EES. So again, this is going to return an array of these instances. If the length of this array is 0, then that means there was no EES windows found, and we should issue an error and tell the user to open the file that they want to run, the EES file. Otherwise, we're just going to use the first instance of EES. So next, we're going to send EES the command to execute the solve command, and what that should result in is the file state.dat being read, the volume being calculated in EES, and the file v.dat being written. So all that's left then is to have MATLAB open the v.dat file and return the number stored in it, which is a specific volume. So the SendMessage command itself returns a parameter, this result, and that parameter is 0 if the command succeeded. Otherwise, it's an error message if for some reason the command failed. So we should check that result is 0. So if it's not 0, then we're going to put up the error. Otherwise, it is 0 and everything went as planned. So we'll open that file v.dat for reading, read the single number in the file, and then close the file. And so now I can test the whole process. I'll just call the function volume, from the command line, and you can see that it returns the specific volume calculated by EES. And because EES is open and waiting, it's fast to call it again and again. So for example, here I'll just write a little script that calls the specific volume for a set of 10 pressures in the array P. And you can see that what I'm going to get back is specific volume at each of these pressures, and I can make a plot or whatever, but you can see that the whole thing runs relatively quickly. So this is a fairly efficient way of having MATLAB control EES if you want to use the functionality of EES from within some other things that you're doing inside of MATLAB.